Hello class, this is Mr. Ezra. The last video we talked about how to solve quadratics with the difference of two squares, which we sometimes call the dots method. And today we're going to talk about how to solve quadratics with the sum of two squares, which we sometimes call the SoTS, S-O-T-S method. So let's get started. First off, when you are trying to factor with the sum of two squares, okay, so when the question asks you to factor, it says factor, and you see a perfect square plus a perfect square. Well, technically speaking, you cannot factor, not without things getting really cray-cray. So what you want to do is you want to instead say, oh, this is not a subtraction sign. The difference of two squares, where we have a minus sign, right? Well, we talked about how to deal with the difference of two squared, how to deal with a perfect square minus a perfect square. This is not that. This is a perfect square plus a perfect square. So what you can do is when you say, oh, x squared is a perfect square, 64 is a perfect square, and this is a plus in the middle, not a minus. Well, in that case, it's non-factorable. You cannot factor it, and the mathematical way to say it's non-factorable is to say that it's prime. Just like the number 5 is non-factorable. There are no factors other than 1 and 5. It's a prime number, okay? This is a prime expression. There's no way to factor it. Well, 12 is also prime. 13 is prime, and 14 is prime. They all have the same problem. They're all a perfect square plus a perfect square. X squared plus 9. 4x squared is a perfect square. 169y squared is a perfect square. And x squared and 121 are perfect squares, but the plus in the middle with every one of these causes us not to be able to factor them. While we cannot factor them, we can solve them. And the quickest and easiest way to solve these kind of equations is to use that square root method that we learned earlier in this unit, which is you move the constant to the other side using addition or subtraction. So since this is a plus 4, I'm going to subtract 4 on both sides of the equal sign to get x squared equals negative 4. And after I subtract 4, I'm going to take the square root of each side, remembering that I squared is negative 1. So when I take the square root of x squared, I get x. Then I've got to deal with the square root of, and it's really, remember, positive or negative square root of negative 4. Square root of negative 1 is an I. And the square root of 4 is a 2. And by dealing with this whole thing of I being the square root of negative 1, I squared. So I, remember, is the square root of negative 1. So it's underneath, it's going to be an I. And the I squared is negative 1. We can deal with all of these together. Okay, so I'm not going to write this as I times 2. Instead, I'm going to write it as positive and negative 2i. So I'll put x equals 2i and negative 2i, meaning 2 times the square root of negative 1 and negative 2 times the square root of negative 1. This one is already, the constant's already on the right side, so I'm going to take the square root of both sides. The square root of x squared is just x. And remember, it's positive or negative. We talked about why that was true before in the previous video, if you need to review that. And negative 25. So underneath this, remember, a square root of a negative under is going to come out as an I. And what is the square root of 25? 5. So we got I times 5, which we're going to write as 5i. It's both positive 5i and negative 5i. Remember, we said that these quadratics always have two roots, so we want to list out both roots and make sure that the teacher, which is me, realizes that you have two roots. All right, so here we've got 4x squared plus 169. Okay. Well, the first thing I want to do is I want to subtract the 169 to the other side. So I'm going to have 4x squared equals, and I'm going to subtract that 0 minus is negative 169. So what I'm going to do here is I'm going to divide both sides by 4. I'm going to get that 4. I really want the x squared by itself. So when I divide both sides by 4, I get x squared equals negative 169 over 4. Now, you might be tempted to use your calculator to get a decimal version, but if you have your perfect squares memorized, you'll notice that 169 is a perfect square and that 4 is a perfect square, and this is going to be easier to deal with by taking the square root of both sides by leaving it in the form that the fraction form that it is in now. Okay, so x is equal to the positive or negative square root of negative 169 over 4. Okay, well, while we're dealing with this, let's switch colors here. While we're dealing with this, I realize that I'm going to have a positive or negative root, right? Inside, the negative is going to come out as an I. And then I've got the 169 on top and the 4 on the bottom. Well, what is the square root of 169? It's 13, right? So now I've got a 13 on top, and the 4 on the bottom, the square root of 4 is 2. So when you do this, when you have a fraction that's all under the square root, you want to take the square root of the top and the bottom. So I've got I times 13 over 2. Well, we'll just rewrite that as positive 13 over 2, I, put the I second, and negative 13 over 2, I. So we get both of those solutions listed out. We want to take the square root of the top and the bottom, and the negative is going to come out as the imaginary number I. Finally, number 18 here. We're going to start working through this. What do you notice about this guy? It's not a plus sign, is it? It's not x to the 4th plus. So this one is factorable, right? We can use the difference of 2 square rule that we talked about before. Well, we'll break it up into x squared in the beginning because x squared times x squared is x to the 4th. We'll break the 256 up into its square root, which is 16. 16 times 16. And we'll have a minus sign and a plus sign, right? Two different signs. We talked in a previous video about why this works. All right, all this is still equal to 0. Now, we can, in this case, factor again, can't we? What can we factor again? Well, again, if you're looking kind of closely, you'll notice that we have the perfect square x squared minus the perfect square 16. So we're going to factor this one again to get x, which is the square root of x squared, x times x, and 4, which is the square root of 16. And again, because of the difference of 2 squares pattern, one of these is going to be a minus and one of these is going to be a plus. Now the other guy is going to come down as x squared plus 16 because he is non-factorable, right? Remember we said he was prime, so the plus sign in the middle blocks this here. But what we can do is we can find now all of the solutions, right? Let's switch colors here to green. So we've got 3 solutions now, or 3 things that we're going to deal with. We actually have 4 solutions. So we have x minus 4 equals 0. We'll go ahead and solve that. That's going to give us x equals 4. We have x plus 4 equals 0. This is what we call the zero product property, that any of these parts could equal to a 0, which would make the whole thing true because we would get a product of 0. We're going to subtract 4 to get x equals negative 4. That's the second solution. And then we can set x squared plus 16 equal to 4. And we now know how to deal with this. We subtract 16 to get negative 16 on the right. We take the square root of both sides. Positive negative square root of negative 16. The negative comes out as an imaginary number. The square root of 16 is 4. So we get I times 4, which is 4i. So x is equal to positive 4i and negative 4i. And since they're kind of scattered about, to make it easier for the teacher to read, we're going to collect all of these solutions into one spot, right? So kind of off to the side, maybe off to the right here, we're going to say that x is equal to, I made a mistake, I just noticed it. Maybe you noticed it. So let's go back in time. I'm not going to erase anything, I'm just going to travel back. I said minus 4 here. I didn't put the negative sign here, so please fix that on your paper if you were taking notes and you were like, wait, Mr. Ezra. It's fixed now. X plus 4, subtract 4 is negative 4. So we've got a 4 as an answer and a negative 4. And we've got a 4i as an answer and a negative 4i. So 4 solutions because it was to the 4th power. And always circle that so your teacher knows, hey, that's my answer. That's what you need to grade, what you look at first. And then you can go back and look at my work and make sure that all is awesome. Well, I hope that has helped you a little bit with the sum of squares. If you're factoring, it's super simple. You just write prime. But if you're solving, you now can solve a sum of two squares. You can't use that shortcut that we use with the difference of two squares. Instead, you have to use the solving by taking the square root of both sides method and the square root method. Thanks for listening, and I will see you in class.